2 is scheduled for next week, so you guys want it to be on next Tuesday or next Thursday?
Thursday.
1 week today or 1 week from Thursday?
Thursday.
Okay, so exam 2 will be 1 week from... Okay, so exam 2 will be on... Now exam 2 will be open book and open notes. And then you'll also want to bring a calculator. And according to the schedule, let's see, exam 2 will cover acid-base equilibria. It'll also cover solubility equilibria. And it'll also cover thermodynamics. So there's really only 3 topics from exam 1. Okay, so speaking of solubility equilibria, let's review quiz 10. So question 1, hard water causes lime calcium hydroxide stains on bathroom and kitchen fixtures. What substance can you use to remove lime stains?
Vinegar.
Yeah, vinegar. What else can you use besides vinegar? Yeah, so really any acid will remove these lime stains. So if you have this equation, we can represent the equilibrium of the solid with its ions. So if you add acid, what's being added or removed so that the equilibrium shifts in one direction or the other? Yeah, so if you add acid, what's happening? Yeah, so if you add acid, that's going to... Okay, so this reacts with the OH minus, which means it removes the OH minus, which means that the reaction shifts toward the reactant side? Oh yeah, shifts to the product side. Which means that more of the calcium hydroxide dissolves. So the other thing you can do is write the chemical equation that represents the reaction between the calcium hydroxide plus an acid. So if you use HCl, what are the products of this reaction?
Water.
Yeah, so the calcium combines with the chlorine, and then the H combines with the OH. So one product is going to be water, and the other product is going to be CaCO2. And then is this equation balanced? Okay, and anything else? Two in front of the water? Yes, you can do that too. So note that, what type of reaction is this? That's an acid-base reaction. Okay, let's go on to question 2. Sugar is used as a fuel provide fuel for our body. Does this reaction produce heat? So for any fuel which burns, is that reaction going to be exothermic or endothermic?
Exothermic.
Yes, that's exothermic. So for question A, does this reaction produce heat?
Yes.
Yeah, so it does. And if we look at this reaction, we have C6H12O6 plus. Let's see, H2O liquid here. So to confirm that this reaction produces heat, we can calculate delta H. And although we covered Hess's law in Chem 1A, I should have done at least one practice problem before the quiz because I'm realizing that a lot of you forgot how to do the calculation. Okay, so let's do this calculation. So the first thing we want to do to apply Hess's law is, even before we calculate, we'll look up the heat of formation. You have balance the chemical reaction or equation. So to balance this chemical equation, we need 6 CO2s, we need 6 waters, and how many oxygens do we need?
6.
Yeah, 6. Then we can go to Appendix 2 in the textbook to look up the delta H of formation. So for any element in a standard state, that's equal to 0. And then we can look up the delta H of formation for the other reactant and products. So for glucose, this is on page A5. It's minus 1247, sorry, minus 1274.5. And for CO2, that's equal to minus 393.5. And for H2O liquid, that's equal to minus 285.8. And then what you want to do to apply Hess's law is that's equal to the sum of the heats of formations of the products minus the sum of the heats of formations of the reactants. And what you want to do is, N represents the coefficient in the balanced chemical equation, so we're going to have 6 times minus 393.5 plus 6 times minus 285.8, and then minus, let's see, 1 times minus 1274.5 plus 6 times 0. And when you do this calculation, now I know many of you are taking calculus, and you might think that, well, this calculation is, gosh, just beneath me. My ex-father-in-law was a mathematician, and he's like in his mid-80s. He still buys math books and studies math, tries to solve these, learn new math. And I asked him, he was talking to me about finances, and I asked him, well, how can you spend more time figuring out how to prepare for retirement? He goes, well, the math is too easy. Didn't want to spend time doing that. So although the math is easy here, it doesn't mean that it's not a valuable calculation to do.
It's negative 2,801.
Minus 2,801. 801.3. And then the units for this number is? Yeah, look at kilojoules per mole. So in other words, when 1 mole of C6H12O6 undergoes this combustion reaction, this amount of energy is released. Okay, so let's go on to the second part. So part B, does this reaction occur spontaneously? So whenever a fuel undergoes combustion, is that going to be a spontaneous reaction? Okay, so let's just write down some information on jump. So for any fuel, okay, so a fuel is going to release heat, which means that delta H is going to be less than 0. And for any fuel, does that reaction occur spontaneously? Yes. Yeah, so for any fuel, it should be a spontaneous reaction. Which means that delta G for that should be greater than 0 or less than 0? Greater than 0. Yeah, so for a spontaneous reaction, delta G is going to be less than 0. Okay. Okay, so let's calculate delta G for this reaction to support your answer. So again, we'll look up the delta G of formation. So let me erase the delta H of formation, replace that with delta G. So we'll do the same calculation we did before. Okay, so this will be delta G formation. So let's see, for C6H12O6, that's equal to minus 910.56. For O2, delta G of formation, just like with delta H, by definition, that's equal to 0 for an element in the standard state. For CO2, that's equal to minus 394.4. And then for H2O liquid, that's equal to minus 237.2. So we'll do the same calculation we did before. So now all we've got to do is plug in our numbers. Minus 2,900. 879.
104.
Okay, so this calculation that George just confirms that this reaction does occur spontaneously because delta G is less than 0. Okay, let's go on to the part C. Is this reaction favored by enthalpy or entropy or both? So what does it mean by when a reaction is favored by enthalpy? Okay, so there's delta G. So we know that delta G is equal to delta H minus T delta S. Note that these two factors determines the sign of delta G. Okay, so for a spontaneous reaction, we want delta G to be less than 0. So if delta H is less than 0, that helps delta G be less than 0. what does delta S have to be to help delta G be less than 0? Pardon? Okay, greater than 0. So if it's favored by entropy, that means that delta H is going to be less than 0. If it's favored by entropy, delta S is going to be greater than 0. So we can answer the first part right away. Is this reaction favored by enthalpy?
Yes.
Because delta H we found is less than 0. Okay, so that's going to be favored by enthalpy. Is this reaction favored by entropy?
We don't know.
Yeah, we don't know. Can we figure out whether this reaction is favored by entropy? Yeah, so we can do it one of two ways. One is by looking at the entropy of formation, plugging it into this equation. So instead of using G, use S. Okay, and then solving for, then calculating delta S of reaction. The other way is note that you calculated delta G of reaction. That was equal to minus, what was it? Minus 2,879. And that's equal to delta H, which was minus, which you calculated a minute earlier, 2,000.